right? Open system interconnection model. We have seen that it is a reference model, right? No one is using OSI as an implementation model. Then what is the implementation model today on the internet? Internet is a major, higher grade, biggest network on the globe. So on the internet, what stack is being used? TCP IP. Yeah. It is the implementation model of today's internet. Yeah. Practical implementation model, and it is also called as Department of Defense model, or in simple DoD model. Why? Because this was introduced to the network by this Department of Defense.
Okay.
So it is a Department of DoD model. It is called as a stack because whatever the protocols that are needed, they are standardized and they are placed one over the other, one over the other, one over the other. You see your CD stack. How do you play CD by CD? One CD over the other, over the other, over the other. Same thing here. That is why it is called as TCP IP stack. Here, first you will be having the layer 2 protocols. Over that, you will be having the layer 3 protocols. Over that, you will be having the layer 4 protocols, and over that, layer 5, 6, and 7 protocols. Yes. So it is a practical implementation model that we used on the internet, and it is also called as DoD model. Right? The difference between the OSI and the TCP IP is on the OSI we have 7 layers, but whereas in TCP IP you have 5 layers. Okay? And it was when introduced. Old model was actually you are having application layer at the top, then transport layer, then internet layer, then network access layer. Only 4. But they have revisited it and they have done some changes and they have come up with application layer, transport layer, internet layer, data link layer, and then the physical layer. This is a new model updated and this is the original old. Okay, whatever protocols, nothing is changed. Okay, only the layer approach is different. That's it. What is this application layer? Application. But whereas in here, so what did they do is, yes, application layer, presentation layer, session layer of OSI were merged and they have come up with a single layer in the TCP IP. and that they called it as application layer. Session. And these three were combined to be a single layer. It is the application layer. Yeah, now whatever these three layers accomplish in TCP/IP, application layer alone will do it, and the transport layer as is, it is the same. Layer 4, layer 5 network layer, layer 3 network layer, and here it has become internet layer. And here it is data link layer, same data link layer, and physical layer, physical layer. Clear?
Clear.
And what are the protocols that we have at application layer? HTTP, HTTPS, DHCP, DNS, SNMP, SMTP, Telnet, SSH, NTP. These are some well-known protocols that work at application layer. Even RIP, BGP. These are the application layer protocols or application layer protocols. You don't need to be worried about it, but thing is, (443) it uses 268, 67, DNS 53, Telnet 23, SSH 22, RIP 520 and 521, BGP 179. You have to be clear with these protocols port numbers, because as of CCNA, these are the port numbers that you will be expected to be known. HTTP and HTTPS both use TCP. Whatever the black circle I have drawn, these protocols use TCP, and whatever the green, they use UDP. Now this blue DNS, it uses both TCP and UDP.
Clear.
Yeah. So you have to know this. Which protocol uses what layer 4 protocol? TCP and UDP are the layer 4 protocols, right? If an application layer protocol is existing, that means a layer 4 protocol at any cost will be used. You have to be careful. You have to know which layer 4 protocol is used. Now the application
Layer
layer.
4 is transport layer.
Yes. Now the application layer data is given after the encryption, after the data is collected, after the session identifier is assigned, the data is given to the transport layer. Here. Now at the transport layer, TCP IP layer will add corresponding layer 4 header to the data. Corresponding layer 4 header to data. See, if I speak about HTTP or even telnet, SSH, whatever it could be. Whatever the data is generated, that data is given to transport layer. Transport layer will check which protocol does this use at transport layer. This TCP, this is hand over to TCP, and TCP will add its information. TCP header. If it is RIP, DNS or DHCP, UDP header is added.
Just one question. You said these are layer 4, right?
TCP and UDP. हाँ.
UDP, right?
Yes.
But we have a TCP IP model. वो तो पूरा मतलब उसमें तो सारी layers होती हैं. I'm confused there.
नहीं. देखो. ये होता है आपका TCP IP. ये होगा आपका लेयर 7, 6, 5 तीनों. ये जो होता है आपका लेयर 4, ये होता है आपका लेयर 3, ये होता है आपका लेयर 2 और ये होता है आपका लेयर 1. लेयर 4 में ट्रांसपोर्ट लेयर है. जो प्रोटोकॉल्स OSI में होता है वही प्रोटोकॉल्स यहाँ पे भी होता है.
मुझे बस पूछना था कि आपने कहा कि जो ट्रांसपोर्ट लेयर है उसी पे UDP या फिर TCP काम करेगा.
हाँ, दोनों में किसी कोई एक काम करेगा ना.
हाँ, मतलब दोनों में से एक कोई
हाँ,
करेगा.
हाँ, हाँ.
अब मुझे ये पूछना है कि ये लेकिन मॉडल तो पूरा ही TCP का है ना, तो मतलब TCP के प्रोटोकॉल्स तो किसी भी लेयर पे काम कर सकते हैं.
TCP IP का मतलब ये नहीं कि सारे प्रोटोकॉल सारे लेयर्स पे TCP IP करेंगे, नहीं. इसका मतलब ये है कि जो लेयर 4 और लेयर 3 में जो प्रोटोकॉल्स यूज होता है, इनमें TCP और IP बहुत ज्यादा यूज होता है. इसीलिए इसको बोला गया what should I say, it was called TCP IP. These are the major protocols, important protocols that work in this model. Practical, yes.
Okay.
And that is why this is called as TCP IP stack.